In this lesson, we're going to look at bond polarity and we're going to look at intermolecular forces. So as we've seen with our bonding, we have forces that are holding elements together. Now we're going to look at the things that hold molecules and compounds together so that they can make bigger chains and they can actually make things that we're used to, like, the water we drink, or, the computer you're working on, things like that. So just a reminder, electronegativity is the strength of our bonds depends on our electronegativity, the ability to attract electrons to ourselves. Nonmetals are higher. Okay, remember, fluorine's the most electronegative, and metals are lower. Okay, that has to go back with our periodic trend. Okay, electronegativity increases as we go across and up the periodic table. In ionic bonds, remember, electrons are transferred between metals and nonmetals, okay? And then electronegativity is not greater than 2, okay? In polar covalent bonds, electrons are shared unequally. So polar, you're unequal. Your electronegativity is going to be between 0.5 and 2. The higher the electronegativity will be slightly negative. The lower the electronegativity will be slightly positive, okay, depending on where, when we're looking at them being bonded together. So if you have a higher En, then that molecule will be the slightly negative one. And if you have a lower En, then you're going to be slightly positive. Nonpolar, you are shared equally. And so your electronegativity is going to be less than 0.5, because you're as close to 0 as you can be, because there's not really a pull on these bonds. Okay, so intermolecular, it holds the bonds together. Okay, ionic and covalent bonds, they have intramolecular bonds. Okay, they're inside the molecule, and these are really strong. It's really hard to break these bonds. Intermolecular holds compounds together to another compound, and these are very weak. These are called your intermolecular forces, or IMFs. Okay, so there's 3 types that we're going to talk about. The first is called London dispersion, or van der Waals forces. They happen between all molecules. Everything deals with London dispersion. Okay, so any molecule, if I ask you for IMFs, you should always put at least London dispersion. I might say, what are the different forces that are holding these together? You can put more than one, but every answer should have London dispersion. They're most notable between nonpolar molecules. That's why I was saying, like, everything has them, but they're the ones that, like, if you're not sure, especially nonpolars, that's what's going to happen. They're caused by random movement of electrons and quick instantaneous dipoles. Those electrons are moving. Sometimes one side will be more positive than the other. The more the electrons, the stronger the London dispersion forces are. So the things that have more electrons moving around, the more the poles can occur. That's why there's more dispersion forces there. But these are the weakest of them because electrons are moving, and you're pretty much hoping that something will stay negative for whatever long you need it. Dipole, they're between polar molecules because you need 2 poles to do this. The positive side of one ion and the negative side of the other ion will be attracted to each other. So if I have a compound that has a positive side and another compound that has a negative side, those are going to be attracted to each other because they're opposites. They're caused by permanent dipoles and the attractions between them. So this isn't because the electrons are moving. It's because the fact that they're already permanently negative and permanently positive. They're the stronger than London dispersion forces, but they're not the strongest. The strongest are for hydrogen bonds. Now, this is a special dipole, but it's between hydrogen and more electronegative elements, particularly nitrogen, oxygen, and fluorine. So hydrogen bonds only occur if another element has nitrogen, oxygen, or fluorine in it. These are the strongest. of the three intermolecular forces. And this actually, remember, between the molecule, so molecule to molecule, not inside the molecule. Okay. So if I had a water molecule, I'd be talking about the fact that the hydrogen bond is between the hydrogen of one, the hydrogen side of one water molecule and the oxygen side of another water molecule, not the hydrogen and oxygen in that one molecule. Weaker IMFs, they have a higher vapor pressure, lower melting point, and lower boiling point, and you normally see these in the gas stage. Stronger IMFs have lower vapor pressure. Vapor pressure has to do with the fact that when water evaporates, that gas that's caused from the evaporation pushes back down onto the liquid. They have higher melting points and boiling points, and normally in the liquid or solid state.